All right, let's jump right into a really critical idea for anyone doing health research, and that's making mistakes. Yeah, I said it. Because it turns out not all errors are the same. And knowing the difference, well, that's absolutely key to doing powerful, responsible science. So, to get our heads around these statistical errors, let's think about something simple, a fire alarm, right? There are really only two ways it can mess up. You've got the false alarm. You know, the alarm's blaring, everyone's annoyed, but there's no actual fire. Harmless, mostly. But then there's the other way, the missed fire. A real, dangerous fire is spreading, and the alarm is just silent. That's a totally different story. That's a catastrophic failure.
Okay, so how does this relate to research? Well, before we can ever claim we've discovered something new and exciting, we have to start from a default position. Think of it as being a skeptic. This starting point for every single test we run, that's what we call the null hypothesis.
The null hypothesis, you'll often see it written as H0, is basically science's prove it moment. It's the default assumption that there's no effect or no difference. It's saying that anything you think you're seeing in your data is just random chance. So, going back to our fire alarm, the null hypothesis is super simple. The building is not on fire. And every bit of evidence we gather gets weighed against that one assumption.
So when we put our data to the test against that null hypothesis, we can get it wrong. And we can get it wrong in two very, very different ways. And you guessed it, this ties right back into our fire alarm analogy.
And here's where it all clicks together. Those two alarm screw-ups, they map perfectly to our two statistical errors. A type 1 error is a false positive. This is when you reject that null hypothesis. You're basically shouting fire when in reality there's nothing there. It's the false alarm. And a type 2 error, that's the opposite. It's a false negative. You failed to reject the null hypothesis. Your alarm stays silent, while a real dangerous fire is burning. That's the missed fire.
Now, this isn't just some abstract stats game we're playing. Not at all. These errors have massive, real-world consequences. And this is especially true in health research, where actual lives are on the line. So let's walk through a practical example to really see why this matters so much.
Okay, picture this. You're a researcher, and you've just come up with a fantastic new screening tool for cancer. It's cheap, it's easy, and it could save thousands of lives. But you have to start with that null hypothesis, right? Your starting point is assuming your amazing new test is, well, completely useless, no better than random chance. So what happens when you make a mistake? Well, if you make a type 1 error, that means your test tells a perfectly healthy person they might have cancer. This is our false alarm scenario. And the consequences? They are very, very real. You're talking about massive anxiety for that patient, not to mention costly and invasive follow-up tests they never even needed. It's a huge burden on them and the whole system.
But what about a type 2 error? Oh, this is our missed fire. This is when a patient who actually has cancer is told they're healthy. The test completely failed. So now they have this false sense of security, they lose critical time for treatment, and the disease progresses. I mean, the consequence here can be absolutely devastating. It can be fatal.
So, you've got to be asking, if these mistakes are so serious, why do they even happen? It's usually not because someone was sloppy. It's actually baked right into the math of statistics. It all comes down to two key ideas that every researcher has to get a handle on, something called alpha and another thing called statistical power. Let's start with alpha. Think of alpha as your false alarm risk tolerance. When you set your significance level, that's alpha, you are literally deciding before your study even starts how much risk you're willing to take of making a type 1 error. So when you see a typical alpha of 0.05, that just means the researcher is saying, I'm okay with a 5% chance of raising a false alarm. And what about those type 2 errors, the missed fires? Well, they're usually caused by a lack of something we call statistical power. And what's power? It's simply your study's ability to actually detect a real effect, assuming one is there to be found. And this brings up a huge pitfall in research. The number one reason for low power is just not having a big enough sample size. Seriously. If your study is underpowered, it might be doomed to miss an important discovery before you even begin.
But here's the good news. You are not helpless here. As a researcher, you can absolutely be proactive and design your studies to cut down on these risks. So think of what's coming next as your personal toolkit for reducing errors.
So what's in this toolkit? First up, you need to thoughtfully choose your alpha level based on what's really at stake. Second, and listen, this is a big one, you have to increase your sample size to boost your study's power. Do the math beforehand to figure out how many people you actually need. And finally, using better, more precise measurements and picking the right statistical test for the job, all of that helps cut through the static and makes a real effect much easier to see.
But, and this is the final super important piece of the puzzle, you can't just get rid of both errors. It's not possible. There's this fundamental trade-off that's just built into the whole system of hypothesis testing.
Just imagine a seesaw. On one end, you've got your type 1 error risk. On the other end, type 2. Now, if you get super cautious about false alarms and you push that type 1 risk way, way down, what happens? The other side of this seesaw goes up. You become much more likely to miss a real fire. So see, your job as a researcher isn't to get rid of all the risk. It's to find the right, responsible balance for whatever it is you're studying.
And that all leads to the final big question you have to ask yourself before you even think about running a test. For your specific research, which mistake is worse? Which one can you absolutely not afford to make? Is it causing a panic over nothing, or is it missing a deadly threat? Because your answer to that question, well, that's going to determine your entire statistical strategy, from the very beginning to the very end.